In this section, we're going to look at the concept of a percent. So we're going to start by just breaking down what the word itself means. So per cent, per means you're going to be dividing by something, like miles per hour. You divide miles by hours. So per, we've got some division going on. And then cent, the root, that word, like century has 100 years. In a dollar, we say there's 100 cents, like the pennies, it's 100 cents. So cent means 100. So per cent means per 100. So if you have n percent, it means n per divided by 100. So if we could write a number as a fraction over 100, the numerator would be the percent. So let's try doing that on these examples. So we've got decimal numbers that we want to convert over to percents. So we'll start with the first one, this 0.45, which is like 45 hundredths, if we say that decimal, that ends in the hundredths place. So 45 hundredths. Then the number in the top, the numerator, that's going to be your percent. So 45%. That's what 0.45 equates to in percent language. 1.26, that's 1 and 26 hundredths, or we could lump it all together and say 126 hundredths, as long as the fraction shows where this number ends, so hundredths. So in that case, the 126 would be the percent. So if you have a decimal number that's larger than 1, that's going to translate to a percentage that's larger than 100%. Now what about this one, 0.005? Okay, that 5 is sitting in the thousandths place, so that is 5 thousandths, which is great. We wrote it as a fraction, but if you want to write it as a percent, it needs to have 100 in the bottom. So the way that we're going to get 100 in the bottom is we're going to divide by 10. But if we divide by 10 on the bottom, we have to also divide by 10 on the top. And I'm going to use some decimals here. When I take 1,000 and I divide by 10, I do get 100. That's what I wanted. When I take 5 and I divide by 10, I get 0.5. So I have 0.5 over 100. So again, the numerator is the percentage. So that would be 0.5%, 0.5%, half of a percent. How about 1? Well, if you wanted to write 1 as a fraction, pick any number you want. You could write it as 2 over 2, 5 over 5, 10 over 10, or we could write it as 100 over 100, because we're trying to get over 100 for all of these, because that means that the numerator is the percent. So 1 is the same thing as 100%. So before I do the last one, I just want to talk about, is there a way that we could do this quicker without having to create a fraction each time? So what I'm saying is there a way for us to avoid the middleman and just go straight from the decimal to the percent? So if 0.45 is 45%, 1.26, 126%, 0.005 becomes 0.5. Like, what is happening with the decimal? It would look like the decimal is moving to the right, to the right, to the right. How many places though? 2 places. So kind of the quickie shortcut, if you want to turn a decimal into a percent. If you want to turn a decimal into a percent, what you're going to do is you're going to move the decimal 2 places to the right. Okay, so that's going to be our shortcut for how you can write a decimal number as a percent. So if you take the decimal, like on part C here, take that decimal, move it 2 places to the right, it would end up right there in front of the 5. So that's the quicker way to do it. 1 is like the number 1 point nothing, right? I guess you could fill in with some zeros. And if you move that decimal 2 places to the right, it makes 100%. So let's use that strategy on this one when we have a repeating decimal. So 0.3 repeating is like this, right? Just a whole bunch of 3s, right? So if I move this decimal 2 places to the right, 1, 2, it would put it right there. So it would be like 33, and then you'd still have a bunch of repeating 3s as your percent. So actually with repeating decimals, that's the fastest way because it's you can't make them have 100 in the denominator nicely. So this is the strategy you'd want to use on those. So 2 places to the right. If you think you're not going to be able to remember whether it's left or right, if you could have one pair that you could use as like the standard, then maybe you wouldn't have to memorize. So maybe if you could remember that a half 0.5 is 50%, maybe if you could just know that, which that may not require a lot of memorizing on your part, you might already know that a half is the same thing as 50%. That relationship shows you that if you want to go from the decimal to the percent, you'd have to move that decimal 2 places to the right. So sometimes just knowing one example saves you from having to like memorize the rule, like making a flashcard.